As the chemicals in this experiment are highly irritable and toxic, proper gloves and goggles should be worn at all times. Materials needed for this lab are 4 beakers and graduated cylinders, potassium thiocyanate, which will make the red color, silver nitrate, which will make the white, and potassium ferrocyanide, which will make the blue. We made a 250 milliliter mixture of 0.03 molar iron 3 chloride, another 250 milliliter mixture of 0.001 molar potassium ferrocyanide, and a 250 milliliter mixture of 0.1 molar silver nitrate.
This is an example calculation of how we found the mass we needed to make the appropriate molarity for a 250 milliliter mixture. We used the equation molarity equals moles over liters, as you can see on the board. In this calculation, we used the chemical potassium thiocyanate. We plugged in our known molarity and volume in liters and multiplied them. We then multiplied the moles of potassium thiocyanate by its molar mass to get the total grams we would need for the mixture. We found that we need 0.04859 grams of potassium thiocyanate for a mixture of 250 milliliters. Le Châtelier's principle, also known as the equilibrium law, is a principle you can apply to reversible reaction. Basically, if there is a disturbance in the equilibrium reaction, the reaction will counteract the change that is taking place to get back to a state of equilibrium. If we, for example, increase the reactance, we can shift the equilibrium equation to the right. This will create more products and return the reaction back to a state of equilibrium. A number of factors can shift the reaction either left or right, such as pressure, volume, temperature, molarity, dilution, removal, or addition of chemicals.
20 milliliters of potassium thiocyanate, silver nitrate, and potassium ferrocyanide were all added to 150 milliliter beakers. Next, 40 milliliters of iron 3 chloride solution was added to the start of the chemical reactions of the color change, beginning the process of reversible chemical reactions, equilibrium, and LC's principle.
By adding 40 milliliters of iron 3 chloride and only 20 milliliters of thiocyanate, we are adding too much iron 3 chloride to the reactant side. To get back to a state of equilibrium, the reaction is going to shift towards the right. This is on the principle of LC. This means that the amount of iron 3 thiocyanate is going to increase, and this compound is what creates the red or dark orange color. This, on a chemical basis, is because the complex ion formation is taking place between the Fe2+ ion and the thiocyanate compound. A complex ion is a species of chemical formed between a central metal ion and one or more surrounding ligands. These are molecules or ions that contain at least one lone pair of electrons. The positively charged metal ion, in this case our Fe2+ ion, acts as a Lewis acid, and the ligands with one or more lone pairs, or thiocyanate, acts as a Lewis base. When we add iron 3 chloride, a double reaction takes place. Out of these 4 compounds that are in the reaction, 3 stay aqueous and soluble in water. Silver chloride, however, is an insoluble opaque white solid, which creates the white color in the beaker that we see here. Silver chloride is an ionic solid. It does not dissolve in water. The ionic bond and its forces holding the solid silver chloride together and its lattice energy are too strong to be overcome by the forces that would favor the formation of a hydrated ion. In this reaction, the chlorine from the iron 3 chloride bonds with the potassium from the potassium ferrocyanide and stays aqueous in solution. The reaction that we are more interested in and will give us the blue color is the synthesis reaction between the Fe3+ ion and ferrous cyanide. These two chemicals bond and give us ferric ferrocyanide. This also goes back to LC's principle, because by adding 40 milliliters of the iron 3 chloride and only 20 milliliters of the potassium ferrocyanide, the reactants have too much iron. To get back to equilibrium, the reaction moves to the right again, which is our product. This product is the ferric ferrocyanide, which gives us the dark blue color that we see here.